Hello everyone, in this video we're going to review the AP Precalculus topics 2.1 to 2.4. Alright, we're going to talk about the arithmetic and geometric sequence, topic 2.1. Now we have arithmetic sequence formula. It could be a sub n equals a sub k plus common difference times n minus k. Whereas a sub n is could be n terms. A sub k is could be k term. Okay, k always less than n. Now here's the hint. You need to find the common difference using the slope formula. Now for geometric sequence, g sub n equals g sub k times r raised to the n minus k, where r is the common ratio, r the multiplier. Alright. Now here's the hint. You need to plug both points into the formula to find the common ratio. Now let's take a look at the examples below. For question 1 to 3, use the information below to write an equation for the following arithmetic sequence. Then find the 11th term of the sequence. Alright, so you have the 4 terms and the 9 terms right here. Now you can treat 4 terms as the k terms and the a sub 9 right here as a 9 term. Alright, so we're going to use the formula right here. So we have equals a sub k, which means a sub 4, right? Plus the common difference, we don't know it, we put d, right? Now k equals 4, n equals 9, right? So it could be 9 minus 4. Alright, now I substitute values. Negative 3 equals 7 plus d times 5, right? Now I'm gonna subtract 7 both sides. So I have 5d equals negative 10, right? So d equals negative 2, right? Now I need to find the 11th term, right? So I need to substitute d equals negative 2 back to this formula right here, right? So I have a sub n equals a sub k. Now, in this situation, you can pick any of this guy right here as an k terms, right? You either pick this one as an k terms or this one as an k term, right? So I'm gonna pick this one. So a sub k, which means 7 minus 2 times n minus k, which means 4. Alright, now I need to solve for 11 terms. So I substitute 11 for n, right? So I'm going to end up with a sub 11 equals 7 minus 2 times 11 minus 4, right? 11 minus 4 is going to be 7. 7 times 2 is going to be 14, right? So 7 minus 14 is going to be negative 7, right? Now let's move on to question number 2. Alright, so the common difference is given, right? So we have a sub n equals a sub k, which means a sub 2 right here. It's going to be 5, right? Plus the common difference is going to be 3 times n minus k. K in this situation is going to be 2 right here, right? Alright, now I need to solve for 11 terms, right? So I have a sub 11 equals 5 plus 3 times 11 minus 2, right? So 11 minus 2, it could be 9. 9 times 3, it could be 27 plus 5, it could be 32. So a sub 11 equals 32, right? Now, question number 3. Now we need to find the common difference d, which is the slope of the line passing through these points, right? So you just use rise over run, right? Going down by 1, so it could be negative 1. Go to the right by 2, it could be 2. So the slope is negative 1/2, right? That is the common difference, right? Now I have a sub n equals a sub k. You can pick any points right here, right? So I can pick this point. A sub k equals 7, where k equals 1 right here, right? So it can be 7 plus common difference. Common difference is going to be negative 1 half right here, right? So negative 1 half times n minus 1, right? Because I picked the first term right here, right? A sub 1. Now, I need to solve for a sub 11, right? So I have a sub 11 is going to be 7 minus 1 half times 11 minus 1, right? 11 minus 1 is going to be 10. 10 divided by 2 is going to be 5. So 7 subtract 5 is going to be 2, right? Now let's move on to the next one. For question 4 to set, use the information below to write an equation for the following geometric sequence. Then find the a term of the sequence. Alright. Now this is the geometric sequence, right? So we know that the formula is going to be g sub n equals g sub k times common ratio raised to the n minus k, right? So you can use g sub 3 as g sub k, right? And g sub z as g sub n, right? Now we substitute over here, we need to find the common ratio, right? So I have 1.5 equals 12 times common ratio 6 subtract 3, right? So we're going to divide both sides by 12. So 1.5 divided by 12 is going to be 1 over 8 equals r raised to the third, right? We need to solve for r, right? So we're going to take cube root both sides. So r equals 1 half, right? Now we need to solve for g sub 8 equals. Now within these two terms right here, you can pick any terms as an g sub k, right? So I pick this one. It's going to be g sub 3 times common ratio is going to be 1 half raised to the 8 minus 3, right? Now g sub 3 equals 12, so I put 12 here, right? Alright, so it's going to be 12 times 1 half power of 5, right? So it's going to be 12 divided by 32. And if you simplify, divide the top bottom by 4. So it could be 3 over 8, right? Now question number 5 is similar to question number 4. I'm going to leave this one for you to practice. The answer must be 384 for the terms g sub 8. Alright, now question number 6. Look at the graph right here. We need to find the common ratio. Alright, we see that the first term right here has the value 6, right? The second term right here has the value 3, right? So we need to find the common ratio by taking 3 divided by 6, right? It's going to be 1 half, right? So now we need to find g sub 8 is going to be the first term right here. It could be g sub 1 times 1 half 8 minus 1, right? Now g sub 1 is going to be 6, right? Value 6 right here. So I put 6 right here. So it could be 6 over 2 power 7, right? So it's going to be 6 over 128. Now if you divide the top and bottom by 2, it's going to be 3 over 64, right? Now let's move on to the number 7, the word problem. Scientists are studying the growth of a particular bacterial colony in a laboratory. The population of the bacterial colony can be modeled using geometric sequence, where the first day of the study is day 1. The population on day 5 was 7,000 bacteria, and the population on day 8 was 32,000 bacteria. What was the population of the bacterial colony on day 7 based on the model? Alright, so here's the key information. This is a geometric sequence, right? So we have g sub n equals g sub k times common ratio raised to the n minus k, right? Now the k term, which means the fifth day right here, right? So you have 5,7,000, right? Now the n term is going to be day 8 right here, right? So it's going to be 8,32,000, right? So we use this point right here, substitute into this formula to find the common ratio, right? So this one represents g sub n, this one represents g sub k, right? So I have 32,000 equals 7,000 times common ratio raised to the 8 minus 5, right? I'm going to divide both sides by 7,000, so r raised to the 8 minus 5 is going to be 3 equals 32 over 7, right? Now I need to eliminate power 3 right here, so I need to raise to the 1/3 both sides, right? So the left hand side should be power of 1/3, the right hand side should be power of 1/3, right? So it turns out to be r equals 32 over 7 power of 1/3, right? Now we need to estimate the population of the bacterial colony on day 7, right? So we're going to use this formula again. So we have g sub 7 equals g sub k. We can pick the fifth day as a g sub k, right? So I have g sub 5 times common ratio, which means 32 over 7 power of 1/3 raised to the n minus k, right? So raised to the n in this situation, which means 7, right? Minus k, which means 5, right? Like that. Alright. Now g sub 5 equals 7,000, so I put 7,000 right here, right? Alright, so I simplify this one, so g sub 7 is going to be 7,000 times 32 over 7 raised to the third, right? Now I'm going to put this one on the calculator, right? So I hit add calculator here. It's going to be 7,000 times, and then the answer right here. Now you want to convert this one to decimal. You just hit menu number right here, convert to decimal, hit enter. So the answer should be question number 8. This is similar to question number 7. The only thing difference right here is the arithmetic sequence right here, right? After 7 minutes, there were 46 people in line, right? So we have 6, 46, right? Now, after 15 minutes, there were 134 people, right? So we have 15, 134, right? Now, question, how many people will be in the line after 19 minutes, right? So we have 19 minutes right here, question mark, right? Now, because it's an arithmetic sequence, so the formula is going to be a sub n equals a sub k plus common difference n minus k, right? We can use this one as a sub k, right? And this one as a sub n to find the common difference, right? So we have 134 equals 46 plus d times 15 subtract 7, right? Alright, so we need to subtract 46 both sides. So it turns out to be 88 equals d times 8, right? So divide both sides by 8, so d equals 11, right? Now we have a sub 19 equals a sub k. We can use this one as a sub k, right? It's going to be 46 plus common difference. It's going to be 11 times 19 subtract 7, right? So it's going to be 46 plus 11 times 12, right? So it could be 46 plus 132, right? So it could be 178. Now let's move on to the next topic, exponential function topic 2.3 to 2.5. Now we have the general form of the exponential function. It could be y equals b raised to the s, right? Now if b greater than 1, this is exponential growth, right? Now you look at the one inside parenthesis right here, b equal to is greater than 1, is exponential growth. Now if a is negative, right, there is a reflection about the x-axis, right? Now this one right here, exponential decay, because b greater than 0 less than 1, right? b equals 1 half right here, right? So this is exponential decay, right? If a is negative, there is a reflection about the x-axis, right? So it could be like this. Now keep in mind, this function is concave up. If you see something like this, half of this one like this, the function is concave up, right? Now if you see something like this, half of this one is going to be like this, the function is concave down, right? The function is concave up, the rate of change is increasing. The function concave down, the rate of change is decreasing. So keep that in mind. Alright, now let's take a look at the first example, example number 9 right here. The graph of the function f is shown above. Which of the following could be an expression for the function f? Alright, now we know that the function f is decreasing, right? This is the decay function, right? So b must be greater than 0, less than 1, right? Because it's going to be right here, right? So we're going to eliminate a, right? Now look at b right here. There is a negative sign in front of a, right? So there should be a reflection over the x-axis, so it should be something like this, right? So we need to eliminate b, right? Now look at d, there is a reflection, so we need to eliminate d, right? Only c is correct, right? Now we can use the y-intercept to check, right? So y-intercept right here is going to be 0, 2, right? So we substitute 0 for s in this situation. The answer must be 2, right? So because f of 0 equals 2 times 1/3 power of 0. It's going to be 2 times 1, right? Because 1/3 power of 0 equals 1, right? So it could be 2, right? So the y-intercept is 2. So the answer must be C. Now let's move on to question number 10. The exponential function g is defined by g of s equals a times b to the s, where a and b are positive constants. The table gives values of g of s at selected values of s. Which of the following statements is true? Alright. Now we look at the table right here. We see that in order to get 24 from 72, I'm going to multiply by 1/3, right? Now to get 8 from 24, I'm going to multiply by 1/3. To get 8 over 3 from 8, I'm going to multiply by 1/3. And this guy multiply by 1/3. Now look at the input value right here. You see that the input values increasing by 1 each time, right? The outputs over consecutive equivalent input value intervals are proportional, right? So this is an exponential function, right? Now, since the common ratio is less than 1, right? So this is the exponential decay function, right? So the answer must be A, right? Because b greater than 0, less than 1, right? Now let's move on to question number 11. Which of the following exponential functions demonstrates exponential growth, which means b greater than 1, right? And a must be positive, right? Now, this one b less than 1, so this is wrong. This one a is negative, so this one wrong. This one b greater than 1, right? So this could be right. Now this is a less than 1, so this is wrong. The answer must be C. Now look at question number 12. The end behavior of an exponential function h is described by the limit statements above. So this one right here. Which of the following could be the function of h of s, right? Now from this given information, we can get a simple graph of this one, right? So when it's come to end behavior, you're gonna put negative on the left hand side of the x-axis, positive right here, positive here, and negative here, right? Now, limit of the function h of s when s approaches negative infinity, right? So when s goes to the left, the function going down, right? Because it's negative infinity, so it should be something like this, right? Negative, negative. Now, limit of the function h of s when s approaches positive infinity. So when s goes to the right, the function approaches 0, which means it's close to the x-axis. So it could be something like this. Alright, so we see that this is exponential decay function and there is a reflection, right? So because exponential decay function, the value of b must be less than 1 and greater than 0, right? So I need to eliminate b and c, right? Now I look at this one, there is a reflection, a must be negative, right? So I need to eliminate a, the answer must be D. Now let's move on to question number 13. The exponential function k is defined by k of s equals 5 times 2 over 7 to the s. Which of the following statements about the function k is correct? Alright, so we know that b greater than 0, less than 1, right? So it's going to be exponential decay function. And the y-intercept is 5, right? So we're going to sketch the graph of this one. So it's going to be something like this. This is the y-intercept 0, 5, right? Now k is increasing. No, k is decreasing because the rate of change is negative, right? If you draw the tangent line of this guy, right, the rate of change is negative. Keep in mind, you have the Christmas tree trick. The rate of change positive is going to be something like this. The rate of change negative is going down like this. Rate of change is 0, it's going to be horizontal line. Rate of change is undefined, it's going to be vertical line right here. Alright, now, so this is decreasing, so this is wrong. K is increasing, this is wrong. K is decreasing, right? So C and D could be right? And the graph of K is concave up. Yes, it's concave up, so the answer must be C, right? Now let's move on to question number 14. Selected values of the function f are shown in the table above. Which of the following claim and explanation statements best fits this data, right? Now from the table, we see that the s values is increasing by 1 each time, right? So this is the equivalent of input intervals, right? Now look at the output. Each time you're going to multiply by 4, right? So the outputs over consecutive equivalent input value intervals are proportional. The answer must be C, right? Now let's move on to question number 15. Which of the following functions is an equivalent form of the function y equals 4 raised to the 3s, right? Now, this is actually exponential manipulation, right? So, you just manipulate this one, right? So, I have y equals 4 raised to the 3s, so I just write y equals 4 raised to the third, and then raised to the s like that, right? Remember, you learned from algebra 1, a raised to the m times n can be written as a raised to the m all together raised to the n, right? Now, 4 raised to the third is going to be 64, right? So 64 raised to the s, the answer must be C. Now, question 16. which of the following functions is an equivalent form of the function y equals 9 times 4 raised to the s, right? And this question similar to question number 15, right? We just manipulate this one, right? So we have y equals 9 times. Now 4 can be written as 2 power of 2 all together power of s, right? So it's going to be 9 times 2 power of 2 s, right? So the answer must be C. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand